So, you want to learn Git, but you don't know where to start. Well, that's where this tutorial comes in. I'm going to show you how to use Git, and I'm also going to show you how to use Git well, how to manage your projects with Git and whatnot. I'm not going to overcomplicate things. I'm going to get straight to the point. I'm going to show you exactly how things are used, and I'm not going to show you everything, but I'm going to show you how I do stuff, how I manage my project versions, etc. Alright, let's get started. So first off, you're going to want a git config. And if you're on Linux, which for this tutorial, for anything operating system specific, I'm gonna assume you're on a Unix-like operating system such as Linux. So, there will be a file in your home directory called git config, like that. .gitconfig. If you click enter on it, or in your text editor, so I'm running Helix, you'll see there, if you're creating this file, there is nothing in here already. So you want to add a user entry, which you just do with square brackets, and then you add your entry. You add your entries, and for me, I added my username, my email, and my default branch name. And by default, Git will choose master as a default branch name, but nowadays people don't really like the name master, so oftentimes people choose main. So you can add that in here. Pull rebase. This is something I recommend doing. I'm not entirely sure what this does, but it makes pushing and pulling a whole lot less painful. So I recommend adding pull rebase. Credential helper store. What this does is it allows you to store your credentials into a file, so then you don't have to manually type them in every time you push to your Git repos. And then these things, I'm not too sure what they do, but I had to add them because on some repositories, when I pushed to them, Git would just refuse, and I think it's because of large files or something. And then status, this is optional. This is just like a nice thing, but this will, when you run git status, it shows your branch, it shows what's in the stash, and it also shows all untracked files. You'll see in a bit, but yeah, so I recommend making a git config, and also side note, you can change these settings, like for example, git config, if you wanted to set your username, which is under the user section as the name entry, the way you would do that is with git config -- global user.name, and then you'd pass in your username. So like, if I wanted to change my name, I could do that like that. I can also edit this file manually. And this username and email has nothing to do with the actual Git service. This is just what the commits will show when you push from your computer. That's what these are. They're not logins for your Git service. All the login usernames and passwords are stored in git-credentials, also in your home directory. I'm not going to show you what's in this, because that would mean compromising all my Git accounts. So I am not going to cat that out. So, alright, let's get started with actually creating a repository. So the way you create a repository is you go where you want to create the repository. So for me, I'm going to go into my temporary directory, just because this is a tutorial. Basically, this /tmp is just a directory that stores files that get wiped when you reboot your computer. So that's why I'm in here. Now I'm going to mkdir test git. This is just the name of my repository that I'm creating here on my machine. This actually has nothing to do with the URL that you're going to have as your online Git repo if you decide to put this on the internet. So I'm just calling this for something on my computer. It's just local. The Git repository doesn't actually care what this folder is called, or directory, sorry. So nothing in this directory. So now I'm going to do git init, and now I have a .git directory. So this stores all the state for Git. This is what allows you to essentially time travel, and if you remove this directory, then this would no longer be a Git repository. So I can do rm-rf git, boom. Now it's just a normal directory again. So I'll do git init again, and as you can see, the default branch is main, so the branch is called main. And a branch is essentially like a timeline. Git is a tool that allows you to time travel, essentially. And main is my timeline. So I don't actually use branches when I manage Git. I use something else called tags, because you can roll back to points in time in your specific timeline. You don't have to create new timelines for every point in your timeline. You can roll back, and that's what I do. I just roll back my one timeline to specific commits, and that's what you call, when you save a point in your timeline, it's called committing it. And you can roll back to specific commits, but commits have these long randomized strings of numbers and letters. That's just how commit names work. I can show you an example. So if I go into my C library, if I do git log, like this, git space log, you can see these are my commit names. But then I also have associated tags with them, so I can just roll back to tag names as well. And the convention is to start tag names with V and then the version that they are describing. That's the convention with tags. So this is an example of like commits and tags. And then this head main is just like this stuff here. This is how you know this is the current commit I'm focused on. This is where I am in the timeline. So, right. So here's my empty Git repository. Now I'm going to create a file called readme.md. And what this file is it's not actually a special file. It's just a convention. This is when you go to a Git repo, like for example, my Hyperland Rice, for example, which is what you're seeing here, by the way. So when you go down on a Git repo and you see something like this, where it's a preview underneath all the source code, let me choose a smaller repository as a better example. oglolib C. So this is that oglolib thing again. So you can see there's all the source code, and then there's this preview underneath. This is pulled directly from readme.md, and it's not like a special thing. This is just a convention that Git forges, which is the formal name for these online Git services, a Git forge. Git forges, by convention, pull this preview from the README. And you can see if I open readme.md, that's what's in here, and I can just go preview the actual code side of things. And it's just plain Markdown. That's it, just plain Markdown. So I'm going to edit this readme.md file, and I'm going to say something like header 1, header 2, header 3, header 4, header 5, header 6, and can I do a header 7? No, I cannot. So I have these headers, and then I can do a block. So like that, it could be a block of C. I'll just write the C hello world in here. Int main return 0, printf hello world \n. So I have the C hello world in here, and then I can do this is a paragraph, the quick brown fox jumps over the lazy dog. And then I could also have in here like a note, hello world, hi there. And then I could have a list of things, so like and fun fact in Markdown, if you just keep doing 1.1.1.1.1, Markdown renderers automatically do 1, 2, 3, 4, 5. They do that for you. The quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog. What else can I add in here? I'll add a table. So like A, B as the table entries. And then in here I'll do like 0, 1, 1, 2, and then like 0, 1, close it. So that's my table, and then yeah, so this will be my Markdown file, and let me just preview it with a plugin I have installed in NeoVim just to make sure everything renders correctly. So I have header 1, header 2, header 3, header 4, header 5, header 6, my see hello world example. This is a paragraph, the quick brown fox jumps over the lazy dog. I have my note here, which for whatever reason added a smiley face automatically. The quick brown fox jumps over the lazy dog, all numbered correctly, and then I have my table. So boom, that's my readme.md file. So now I'm going to create something called the gitignore file. What this is it's useful for if you need to create files in the Git repository, but you don't want Git to know about them. So you want Git to just completely ignore them. They're not going to show up in the repository online or the Git status. They're just ghost files. They're just there solely because you needed to put them there, but you don't want to track them, essentially. So the way I'm going to do this is I'm going to create a file called .gitignore. So now I have this .gitignore file, and what I'm going to do is I'm going to put file names in here. So you could put file names, directory names in here, whatever. So first I'm going to specify / for the project root, basically just the project directory, not actually the root directory on my system, just the project, like the Git repository. And then I'm going to do, or actually I've heard that you're not recommended to do that, so what I'm going to do instead is I'm going to, well actually it's fine, but I'm going to specify file names. So I'm going to say myfile.txt. I want this to be ignored, and then I also want my directory to be ignored. So these files and directories don't exist because I haven't created them, but I can. So first I'm going to do touch myfile.txt and mkdir my directory, and touch in my directory hello.txt. So now I have this directory in this file. And I should also note that if you add something to the gitignore after Git's already been tracking it, Git won't untrack it. It will just track an older version from before you added it to gitignore. So if you're going to gitignore files, make sure to do the gitignore first, then create the files. Just a quick thing that I learned the hard way. So now if I run git status, you can see gitignore is a new file and readme is a new file, but there's no mention of these two these two items, and also .git is not specified because .git is the state directory. There's like, yeah, it's special. So now what I'm going to do is I want to put these on GitLab, which is my Git forge of choice. So what I'm going to do is create a new repository. So up here, just the plus sign, create blank project, test repository, and I'm just going to pick my namespace, and I'm going to do oglo12. That's my username. Test repo, I'm going to shorten the slug to test-repo. This is what actually shows up in the URL. I'm going to set it as a private repository just because this is a tutorial. I don't want it to be public. I'm not going to initialize it with the README since I already have one. Experimental settings, not going to touch any of that. Then I'm going to create project. I'm going to create project. And it turns out I already created a test repo. Interesting. I'll call it tutorial. Yeah. And then I'll do all that again. So don't initialize with README. Create, and now I have this tutorial repository. So the way I'm going to interact with this is I'm going to copy this URL, and then I'm going to go back to my Git repository, and I'm going to add the files that I want to commit. So I want to add everything in this directory. So I'm going to do git add period. Period is just like a thing in bash that says this directory, so the directory I am currently in. Period. That's what period is. So I'm telling Git to add everything in this directory. So add this directory. I do git add period, and now if I do git status, you can see these two files have been added, and if I run a git commit, then these files in green will be added to the timeline snapshot. So git commit -m. And this has interesting properties. Like if you're working on something in your Git projects and you only want to commit some of the files, but you want to keep working on some of the other files without them being in a commit, then you can add the specific files you want to commit. And the other files will just stay as files that you created but didn't handle. So I'm going to do git commit -m for message. -m is for message. And then I'm going to type in my message here. So I'm going to say, just created the repo. So that is my commit message. And if you mess up a commit message, you can do git commit --amend. And it will open it up in a text editor. And you can also change this text editor through the editor variable. So like, if I don't want it to open in NeoVim, I can just set the editor environment variable to, for example, Helix, and it will open in Helix. Yeah, so, all right, so yeah, now I have this commit, and if I do git log, you can see that commit. Now I'm gonna tag this commit. So I'm gonna say git tag, and you don't have to tag everything in every repository. I'm just doing this as an example. Usually you would only tag commits in repositories where you actually have a file that says like the version of the project. So the tag just reflects the version of the project. I'm going to say this is version, so I'm going to say v0.1.0. So v0.1.0. That is the version of my repository. So now if I press enter and I do git log again, you can see this tag 0.1.0 is essentially an alias for this commit name. That's how you can think about it. And now, if I want to sync it up to this online repository, I copy the URL, and then I do git remote add origin and then the URL, and I add .git to the end of the URL. Do note that some Git forges don't know what to do with this .git on the end, but usually, like if you're using the big like GitLab, GitHub, Codeberg, Bitbucket, etc., then you would add .git. Yeah, so .git. And then after that, you press enter, and this will create a remote named origin that points to this URL. And the way what you do with that information is, after you have all your commits made and stuff and you want to push them up to that repository, then you do git push -u origin main. What this does is it pushes stuff, and then -u sets the default origin, the default remote and branch name to whatever you pass here. And if I press enter now, it will push. And you only need to do this once. After that, anytime you make changes, like if I do a new file called like hello.txt, but here in the project root, and I go into hello.txt and I say the quick brown fox jumps over the lazy dog, and I save this. Now I have this hello.txt. If I do git status, it's an untracked file, so then I can do that to track it when I make a commit. And then I do git commit -m, and I'll do hello.txt. And now if I do git log, you'll see that commit, and I'll tag it with a new version name. So like git tag v0.1.1, git log, git push. Git log. So this just means this is my focused commit, and this just means it's up to date with the repository. So like I pushed it. So now if I go over to my web browser and I refresh this and remove this £, I don't know why it adds that for new repositories, you'll see my README gets rendered here. I have my table, my items, my note, my paragraph, my C code, my headers, etc. And you'll see I have hello.txt in here, and git ignore with my stuff in it, and you'll see those files in git ignore don't show up in the project. You'll see the commit names for the commits that added these files, and I can also, okay, I actually forgot to mention, for tags to show up in your repository, you have to git push adds normal files and folders, and if you also, side note, you can also delete files and do git add period, and it will also say like deleted file, and you can do that in a commit message and whatnot. So I'm going to do git push --tags. When I do git push --tags, what that will do is it will also push the tags. So now you'll see in here I can see the tags. And if I click this, so you can see hello.txt is in the newest version of my repository. I can click on 0.1.1 to see the repository at this version, and then 0.1.0, and you'll see the hello.txt just doesn't exist in this point in time. So I'll go back to the newest commit, which is the main branch. So now let's delete hello.txt. So now if I do git status, you'll see deleted hello.txt, and I can do git add period, and then git status, git commit, now that it's in green, git commit -m, deleted hello.txt. Sad face. Now if I do git log, you'll see that commit. And I can tag it with a new version if I wanted to, so like git tag v0.2.0, for example, git log, git push, and also remember to do git push -- tags. So now if I go back to my repository here, you'll see deleted hello.txt. And the hello.txt file is no longer here, but I can go back in time and it's here again. This is why you never want to store passwords or anything like that in a Git repo, because even when you delete them, you can still time travel back to when they were in there. So yeah. Now, what about when someone else makes a change to your Git repo? So I believe I can do that here in GitLab. Like, for example, create a new file, and I'll call it from gitlab.txt. Hello from the lab. Smiley face. Commit changes. I'll say added a very cool file. Commit changes. So now I have this file in my repository from gitlab.txt, but I don't have this file in here. So let's say I wanted to do another change in my repository. So like touch touch grass.txt. Grass.txt. And I'll just put like jigger, seed, booger, soil, etc. So all the stuff you would find in grass. Git status grass, git add period, git status, git commit -m, touch grass, git log. You can see I have that commit. And this time I'm not going to bother with adding a tag, because the tags are just aliases for the commits. They're just easy to remember aliases, essentially. So now if I do git push, you'll see that I can't. It says rejected, error failed to push to ref, and updates were rejected because the remote contains work that you do not have locally. So what I have to do in this situation is I have to do git pull origin main. So git pull origin main will pull down whatever I did on that repository or whatever someone else did and pushed up to the repo. And when I say someone else, I mean a maintainer. Like, no random person can just do stuff to your online repository. Like, you have to explicitly give people permission, obviously. So now if I do git push after git pull, it can push to GitLab. And also, side note, if you do git pull origin main, much like the tags, if you want any new tags that were created by someone else, you also have to add -- tags. And I should also note that -- tags only does tags, whereas this does everything else. So, and that applies for pushing too. So if you git push, you'll end up doing git push and git push -- tags separately. If you do git pull, you'll do git pull origin main and then git pull origin main -- tags. I should mention that. So now if I refresh this, you'll see my commits here. So everything works properly. I can see my commit history. Yep. And you can also see like the tags. And I can also, yeah, so this is a repository, and that's how I manage my Git repositories. I just do tags and stuff. And then to roll back to a commit, you do git. So let's roll back to let's roll back to when I had hello.txt in here. So if I git log, you'll see this deleted hello world this deleted hello.txt. So I want to roll back to the commit right before that. So I could copy this whole string, but since I actually have a tag here, I can just copy the tag, and then I can do git checkout and then paste that tag name or the commit name. Either one works. And then when I press enter, now if I ls, you'll see hello.txt is in here and all the new stuff is not. So that is how you can roll back to previous versions of, like, previous states in your Git repositories. And I don't actually know how to get back. So I did a quick search, and the way you get back is you do git checkout main. Main is that branch name. So git checkout main. If I do git checkout main, I'm back here. Git log, you'll see everything is here. So that's how, like, that's really all I have to say about creating repositories. Now, just the simple stuff like downloading repositories. The way you can do that is I can do git clone, and then I want, let's say I want to clone my C library in here. I'll just do git clone https://gitlab.com oglo12 oglo libc .git, and then optionally after this URL, like if I just hit enter here, it will create a directory called oglo-lib-c, but I can specify a folder name or directory name, and I'll call it oglo lib like this. So now if I hit enter, it will clone all the commits, and then I can change into that directory, and boom, I have this repository locally. And then I can create changes and push them up because I'm the owner of the repository and stuff like that. And then this license file, this is another thing. You add a file called license, all in caps, to the root of your project, and that's how you add licenses to your projects. Like that. Alright, so let's say you're cloning a really big project. So let's say I'm cloning raylib. github.com's raysan5 raylib.git. Let's say I'm cloning raylib. This is going to take a long time if you have a slow internet connection. I'm blessed with a semi-fast internet connection, so this does not take too long on my system. Now, let's say you're not so lucky and you have a very, very slow internet connection. Let's say you're only cloning raylib because you just want to look at the code or use it or whatever. You're not interested about the timeline, you're just interested about the files in the repository. Well, when you git clone something, it actually clones all the commits along with it. So what you can do if you just want to clone the repository, you can, after this git clone, you can do --depth equals 1. And if you do this and press enter, it will only clone the one newest commit. I can do like --depth is equal to 5 to clone the newest 5 commits. To do that if I wanted to, I'll do that, for example. --git. But if you only want the newest commit, you can do 1. So I'll do 5. And now if I clone this, it's a lot faster. Or I actually don't know, but yeah, you can see I only have, I don't know why that didn't work. Maybe I don't understand dash dash depth. Maybe. But if I do 1 cd into raylib git log, yeah, now I have only the 1 newest commit. So it's a lot faster to clone. So that's how you do like quick clones. And yeah, so that's cloning in Git. Now, what if you create a project and you want to add dependencies, but you don't want to literally git clone, because you can't. It's not a good idea to have Git repositories cloned inside. It's not a good idea to have Git repositories cloned inside Git repositories. So what you can do, like for example, if I go to my C library again, or actually, that's not a good example because the only dependency I have is the the standard C library. I actually don't have any good examples of this, but let's say, or yeah, actually I do. gitlab.com/oglo12/simple OpenGL examples. Looks like I spelled that wrong. So now I have to search for it. Where did I put it? I have a lot of repositories. Is it C OpenGL examples? Yeah, I think that's what, yeah. So if I go to this repository, you'll see that under deps, I have this CGLM, but it looks a little weird. That's because I added CGLM as a Git submodule. So this is basically how you can embed Git repositories inside of a Git repository. So this CGLM is actually a reference to a specific commit at this specific Git repository. So how you can do this, so you basically have a Git repository that references Git repositories, is you can do, I'm going to create a folder here called submodules. So now I have this directory called submodules. And let's say I want to add one of my other repositories as a submodule. So like C OpenGL examples. I know this is a nonsense example, but I'll do git submodule add, and then the URL .git, and then I'll put it in submodules, and I'll put it as COE. That's what I'm going to call the destination. Now when I hit enter, it will clone into COE, and if I do ls submodules to the point of the operating system, it's just like a normal folder, but to Git, it's actually added as a subdirectory or a submodule that the main repository can track. So yeah, that's how you can do that. And I'll do git commit -m C OpenGL examples as submodule. If I do git push and I go back to my repository here, you'll see now I have a folder called submodules, and if I go in here I have COE. If I click on that, then I can open this, yeah, and I can also click on it and go to at the specific commit that I added it. Yeah, so that's submodules. Let's say you want to remove a submodule. So ls submodules. Let's say I want to remove this. The way you would do that is you would do git submodule dinit -f submodules, and then this, and that will clear it. And then you want to do git rm-f submodules and then that directory, that will remove it. And now if I do ls submodules, it's no longer there. And also, just a side note, Git does not add empty directories to your Git status. So now if I do git add, just in case I missed anything, git status, git commit, I can do removed submodules. And I can do git push, git status, everything's up to date. And now if I refresh this, I no longer have that submodules directory because it's empty. Obviously I don't have that submodule in here anymore. Let me go ahead and add that submodule again though, because there's something else I want to show you guys. I'm going to do git submodule add. Oh, interesting. I want to do -- force. What's it saying up here? If you want to reuse this instead of cloning again from do use the if the local git is not the correct yeah. So I guess I'm going to add -- force after this add. So after add force. And if I ls submodules, yeah, so it's back. Git status, git commit. It's back. Yippee. So, right. So now that this repository has a submodule, this brings up an interesting problem. When you clone this repository, so I'll clone this, so git clone .git, and I'll clone it as tutorial clone 1. So if I clone this and I just do a regular git clone, there's a problem. This COE directory is empty. And this is because I actually need to clone recursively. So I'll clone again. So I'll do this time tutorial clone 2, but after git clone, I'm going to add -- recursive. So now this will recursively clone. You can see it's cloning into tutorial clone 2, but it also clones all the submodules and also checks them out to the specific commit and whatnot. So tutorial clone 2. So now if I ls submodules, you can see this directory has stuff in it. And I can ls directory and it actually has all the stuff in it. Now let's say you did clone non-recursively and you don't want to clone again because it took a while to clone. So the way you can resolve this is do git submodule init. And what did I do wrong? Or did I do it right? No, I did not. Git submodule update. Right, so yeah, you have to do git submodule init, and then you have to do git submodule update. And then now it's there. And that's how you resolve missing submodules if you did not clone recursively. You do git submodule init, and then you do git submodule update. Yeah, so that's what you do. And then I'll just remove this tutorial clone 1 and tutorial clone 2. Test Git. So yeah, that's my tutorial for Git. I hope you enjoyed. Have fun, write lots of code, send me what you make, and as always, have a good day. Bye-bye.